Okay, so this is the last example that I want to do with you. So the first thing we're going to need to do is to do a lot of factoring. And of course, we need to find our excluded values. I will start by factoring some of these two first because they're the simplest. Now, when I'm factoring, the very first thing I look for is a GCF, a greatest common factor. So I see that there's no GCF here, but this is a case where I have a leading coefficient of 1. And so those are pretty easy to handle because I'm really just looking for numbers that multiply to equal 2 and add to equal 3. So numbers that multiply to equal 2 and add to equal 3. Well, the only factors of 2 are 1 and 2. 1 times 2 is 2, and 1 plus 2 is 3. Remember that when you factor, you should always check the outer and the inner terms and make sure that their products have a sum that's equal to your middle term here. So your outer products and your inner products, 1 times x is 1x, x times 2 is 2x, 1x plus 2x is 3x, so that's factored. Over here, we do have a GCF. The GCF here is x, so I can factor out x. And now, what times x is x squared? X. What times x is 3x? 3. Now, when I look here, I am going to end up with 2 binomial factors. However, I have to work that out separately because I can't simply look for numbers whose product is -10 and their sum is -1 because this leading coefficient here is 2 and not a 1. So I'm going to kind of come over here to the side and work that out. In fact, I'll get another piece of paper and do that. So what we're trying to do is we're trying to factor 2x squared minus x minus 10. So we are still going to use our x method. However, the top number that we're going to put here, because remember, we're still looking for a product and sum combination. This product that I'm looking for comes from the leading coefficient times the constant. 2 times -10 is -20, and I am still trying to get that middle coefficient, which is -1. Now I see that, oh, I'm looking for numbers that multiply to equal -20 and add to equal -1. Well, my choices are 1 and 20, 2 and 10, or 4 and 5. Ding, 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 ding. So that's what we're going to use, 4 and 5. And then the sign of this number always goes to the largest of the two. And that makes sense because remember, I'm going to add them and they need to equal a -1. So that larger term needs to be negative. So I'm still working on factoring this. So now we're trying to factor 2x squared minus x minus 10. So what I do is I come back and I rewrite that into a polynomial in 4 terms. And what's going to happen is this middle term is going to be broken up into 2, the sum of 2. And it will be equivalent to the original expression, but it's just written in a different way. So in other words, I can write -1 as -5 plus 4. So that means I can rewrite this as 2x squared minus 5x plus 4x minus 10. So this expression is identical in value to this one. 2x squared, -5x plus 4x is -1x minus 10. So this is the factor by grouping method. So I'm going to add parentheses, and here my GCF is x. That leaves me with 2x plus 5, or 2x minus 5, sorry. And here my GCF is 2. That leaves me with 2x minus 5. Notice I get the same thing twice. So now my answer is 2x minus 5 because that repeats. That's like a new GCF just for this line. And then what's left? X plus 2. All right. So 2x minus 5 times x plus 2. So coming back here, I'm going to write this as 2x minus 5 and x plus 2. So now I can see what my excluded values are going to be. And I'm going to have several of them. I'm going to have -2, -1, -3. We already listed -2, and this one is going to be 2x minus 5, which equals a 0. So I'm going to come down here and do that. So my excluded values are going to be also 0 from here. So 2x minus 5 equals 0. 2x equals 5. X equals 5 over 2, 5 halves. That's one of them. Also, I have -2. I also have 0, -3, and -1. So all of these 1, 2, 3, 4, 5 numbers are my excluded values. So now, to finish this problem, this is a longer one, okay? This is pulling in skills from first semester. And so we need to factor where possible in our numerators. This is already broken down. Here I have a GCF of 2x squared. And that leaves me with 1 plus 2x. And here I have a there's no GCF, but this is an easy factoring problem. Numbers that multiply to equal 3, but add to equal 4. That will be 1 and 3. So now, let's kind of rewrite this. So this now can be represented as x plus 1 times x plus 3 over 2x minus 5 times x plus 2 times 2x squared times 1 plus 2x over x times x plus 3 times x over x plus 1 times x plus 2. Now remember, be sure to pause the video whenever you need to go back over something's confusing, you need to hear it again, all right? Okie dokie, so now we get to do our canceling. Remember, we cannot cancel until we get things into their factored form. So let's see. Ooh, I think I'm gonna get to cancel a lot of stuff here. Ooh, look, x plus 1 and x plus 1. This is the fun part. I love canceling. It's like a game. X plus 3, x plus 3. Let's see, x and x. Anything else? I don't think so. So we have left a 2x squared and 1 plus 2x. 2x minus 5 and x plus 2 and another x plus 2 over here. So let's consolidate all of that. So I'm going to have 2x squared times 1 plus 2x over 2x minus 5 times x plus 2. Now check this out. Since I have two of these, I wrote it once and I put a square on it. And we could go ahead and distribute this, but typically we leave the bottom in factored form. So that would be 2x squared plus 4x cubed over 2x minus 5 times x plus 2 squared. Woo! That was the answer. Okay, so remember our excluded values are here as well. Right there. Try to get all that in the screen. All right. So what I challenge you to do in this situation is to get out a piece of paper and try doing this problem by yourself from scratch. Watch the video, start the problem, pause it, do the next step, let it go, check to see if you did it right, until you can do this problem by heart. and you could teach it to someone else. If you can teach it, then you know it, right? Okay, guys, that's it. I'm out of here. That was 10 minutes on one problem. But please remember that I'm going step by step and I'm explaining everything, and that's why it took a little extra long, okay? All right. Take care. Bye-bye.